Hi, I'm doing this video to help you with composition of functions. So the number of bacteria in a refrigerated food product is given by this function n of t. And it's 24 t squared minus 154 t plus 91 when t is between 6 and 36, where T is the temperature of the food. When the food is removed from the refrigerator, the temperature is given by this capital T of little t, which is equal to 8t plus 1.2, where T is a time in hours. Find the composite function n of t and give it there. And then they ask the second question after that. So let's just work on this first part and make sure we get this first part right. Composition of functions. So what they're asking us to find this n of t means that where we used to just have the capital T in the equation, we need to plug in the whole function T of t in for just that single variable T. And that is a little bit unnerving for some students. They just, I guess, what's the word? Like, it's hard for them to accept that that's what we need to do. So see how they have replaced this T with a whole expression T of t. So we need to replace where we see the T everywhere in the function, we need to replace it with what T of t is. It is at 8t plus 1.2. And remember that a function, it's kind of like a little machine. It has a little spout. There's like an input, something that's being input. Kind of, that's not a very good picture of how I wanted to draw it. Basically, I'm thinking of like a funnel. And you have the input that goes into this funnel. And then it has an output. So something goes into it, then the function does its thing, and then it spits something out, an output. Okay, and so what we put into this input could be a single number where we're substituting a single number for letters, and that's what we're kind of used to doing in math, or it could be a whole expression. But this T represents just kind of this funnel where it's just holding that value that we're going to be inputting for it's like a placeholder for the expression or number that we're going to be plugging in for it. Okay. So T of t, well, that is 8t plus 1.2. So I'm plugging in where I used to see the t, I'm plugging in 8t plus 1.2. I'm plugging in a whole expression for a single variable because this t is just the funnel. It's just the waiting place that waiting to receive something, right? So in place, I'll just write down here. It's the 24, and in for t, I'm going to plug in 8t plus 1.2. And then everywhere I see the t in the function, I have to plug in the 8t plus 1.2, and it's a good idea to always plug things in parentheses. It's good when it's just a single number, but it's especially really important right now that that's going to cause you problems if you don't do that. And then the 91. So let me just double check and highlight. See, I have a t here, and ooh, I'm glad I double checked because this should be squared. That's a common mistake that most students make. See, where the t is here, it became t. I'm gonna put the square on it too. The t got replaced with 8t plus 1.2. And then I carried down that square that was still on the t. I carried it down, it's still down there. Okay, and then this t got replaced with 8t plus 1.2. And then let me just double check that everything that, okay, so this is now what it should be, but then the t24 is still in front of it. Okay, and then the minus 54 is still in front of the t. And then the plus 91 is in front. So all these black things, you have to make sure to just rewrite those items down. And if I forget something like the 91 and I'm distracted, I don't write every single thing in black up here, rewrite it down here correctly, then I'm going to get this problem wrong. And also, if I don't rewrite and replace the t everywhere with this expression, 8t plus 1.2, then I'm also getting it wrong, right? The big mistake here is like, I almost made it, was this has a square here. So I have to make sure to put a square on this 8t plus 1.2, okay? Now I have to just use order operations, and I have to just simplify this. So exponents would go first. So I had to go off to the side here and do 8t plus 1.2 squared, and I have to be very careful that that means 8t plus 1.2 times 8t plus 1.2. So I have to do the first times the first, that'll be 64t squared. Right, 8 times 8 is 64, t times t is t squared. Then 8 times 1.2, I'll just calculate that quickly. It might be, if you don't have a calculator with you, it's easier to turn that into a fraction. But let's pull up a calculator. 1.2 times 8 is 9.6. So 8t times 1.2 is 9.6, and I'm going to do 1.2 times 8 again, so another 9.6 t, and then at 1.2 times 1.2 is 1.2 times 1.2, which is 1.44. Okay, so I have to recognize that this, all of this big mess, that just gets replaced by this, right? So I'm still have to really be careful. I still have to put the 24 in front. Then I'm substituting in for the red stuff, this 64t squared plus, and I'm going to combine the like terms in the middle here. So 9.6 plus 9.6. 19.2. And I have to make sure to put all of that in parentheses because all that's getting multiplied by 24 in the front. Okay, and then I can distribute these out, right? So 154 times by 8 equals 1,232 t. And then I give you 154 times 1.2. So 184.8. And this is minus, right? And negative 154 times positive 8 is going to be negative, and then negative times positive is going to be negative again. So it's negative 184.8. And then plus the 91. Now I combined all, or I distribute this out again. All right, the 24 times all three of those. So I get 24 times by 64. And good thing I'm letting you guys use your calculator with this, right? Because that would be really bad. This would be really hard. "24 times 19.2. We get 460.8 T. Okay, then 1.44 times 24, 34.56. Then I'm just going to just copy everything down. I'm not trying to do like too many steps at one time. But I probably can combine those, like those terms. So 184.8 minus 91 plus 93, so it's still going to be negative 93.8. Okay, now I kind of combined any like terms that I have here. I combine these t's together, so that would be the 1232 minus 460.8. So I get that would leave me the negative 771.2 T. Oh, careful, I forgot my T. Oh, there's the T. Ah, that's what's so hard about this T. There should be a T and a plus sign here. And so I got confused. I confused myself because my T looks so much like a plus sign, which I'd really encourage you to try to maybe, I just almost made a mistake because of my handwriting. Maybe kind of make your T a little bit slanted, and I put like a kind of a U curl at the bottom of my T to make it a little bit different looking sometimes than a plus sign. So let me just review this. This is supposed to be 24 times 19. These two multiply together, I got this first number. Then these two multiply together, I got the 54608, but there should be a T on the back, and then it should be 24 times this plus the 34. Okay, then this should be negative. That should be negative, and then the 91 is positive. Okay, that looks better now. And let me rearrange this, and let me put this curly T on the back. Okay, so I'm just going to rewrite the first term. It's kind of better to do this on using regular notebook paper. It just is kind of when we do it on the computer, where it's just not as easy as on notebook paper. So that's something that's going to hold us back and make it harder for us as well. But then I just need to add, I need to take 93.8 minus the 34.56, and then I get this, oh dear, and I made a mistake, 93.8 minus 34.56 equals, okay, 59. So it's going to be negative 59.24. And that is our completely simplified expression for this first answer. So let's just double check it. And there's a lot of things that could have gone wrong. I did a lot of calculations. There could have been a lot of typos. It's good to kind of go slower and watch as you're entering each number so that you don't make mistakes. But oh, and they kind of leave it. Oh, and this is not the same problem. Oops. That's not the same problem. Let me, it's actually kind of, I can tell that it's 27 T squared and we have 24 T squared. All right, so I kind of looked back through my work and I just was double checking my calculations. it's nice when you write every step out because you can double check calculations. I didn't find any errors. However, there is a lot of work here. That's why we have to be really careful doing our calculations. But hopefully I did not make any errors. And so this answer for the first part, find the composition of these two functions, is this equation right here. So I can plug that in. That's the 15.36t squared plus 460.8t minus 59. Oh, wait, oops, look at me, and I'm not even able to write this. Okay, minus the 771.2t minus 59.24, I believe. Yeah, okay, so that's the answer to the first part. Now the answer to the second part, find the time needed when the bacteria count reaches 338.0. So find the time needed So let's think about these functions for a little bit. This function, if I plug in a time, then it will give me back a temperature. And if I take that temperature and plug it into this function, then it will give me the number of bacteria. So this N of t, when I plug in a time, it'll give me the number of bacteria. So find the time needed when the bacteria count is this much. So we do need to kind of plug into this given function that we just found. Be very careful. We are plugging in for what I would refer is the y coordinate, it's the output value, not the input value. So 3380 is into this function that we have. They're going to plug in a time for t. And this function spits out a number of bacteria. I like to, even though we have this big notation N of t right here, I like to just replace it with the variable y, because it is just one variable right there. So, I mean, all that extra parentheses and extra numbers are just describing what the variable is. We could easily just use a y right there and use a paragraph to explain what the y is. So when we have an equation, we can plug the two things they love to ask us to do when we have an equation and they ask for a particular value is they love to plug in for either the independent variable, which is what the equation is in terms of. That means, what does the equation sound like? To say, 15x plus 7x plus 3, that everything is in terms of x, okay? This one, everything is in terms of t, the time. So that's our independent variable. Given a time, this function is going to spit out the number of bacteria. So what we need to do here is plug in for the output variable, because the output is the bacteria count. So let me erase this part down here. This is where I'm going to plug in the 3380, where the y is. So I'm going to write it out 1536 t squared. I'm going to make my t a little curl at the end, like minus 771.2 t minus 59.24 equals, and I'm going to plug in for the y .3380. Now it's a quadratic equation and I need to solve for that quadratic equation. So I subtract from this 380 from both sides. This gets me 1536. I just need to carefully, meticulously write out all of these other things. And then I subtract, I'm subtracting, it's already negative. The 59 was already negative. So I'm going to add those together. I'm going to get 34, and I have to be careful, it's a negative 3439.24 equals 0. Now this is a quadratic equation, and now I'm seeing that this is going to be, it's a really large number, so it is not going to be a pretty number to do, now that I think about it. And even our calculators might have a hard time doing such a large number like this. So let's look at, we're going to have to do negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So this is our a, that's our b, the negative, and this is our c. It's negative as well. So the negative 771.2 plus or minus the square root of negative 771.2 squared minus 4 times a, which is the 1536, times by the c, which is negative 3439.24, all over 2 times 1536. All right, and then now we just have to plug this into our calculator and do some calculations. That's going to be positive. A negative number times by itself is going to be positive. But 771.2 to the second power, 771.2 is this really large number, but it's going to be a positive 771.2 plus or minus underneath the square root is going to be 594,749.44. And then now I'm going to multiply all those numbers together. Let's see what I get. 4, and notice how that I have 2 negative signs there, so I know that I'm going to be adding whatever this answer is. So 4 times 1536 times 3439.24, and we get this 21130.690.56 all over 2 times 1536, which is 7072 or 3072. Okay, let's see if my calculator will do this. And you might have to get another, if you're trying to just use like a scientific calculator, you might have to get a crafting calculator. Ooh, let me put this in parentheses. Okay. All right, so I put all of this underneath and I added these two big numbers and I then, well, I clicked, when I did this in the calculator, I clicked on square root symbol and then I put open parenthesis and then I put those numbers added together and then I closed the parenthesis and then I got this 4,661.05567. That is the answer when I did this square root. I'm gonna do this mess of the square root. Now I have this problem. There's two solutions that are coming from this problem. It is the 771.2 plus 4,661.05567. And then make sure it has equals and get the number in the numerator. So that gives me, well, let me write out what I did. I write every step. It's tedious, but you can check your answers. And when you look back, it's very helpful. Then I added the two numbers in the numerator and I got 5,432.2 5567 all over 3072. And now I'm going to divide the answer. And I get this 1.76. And let's see how many hours they want us to. I'm gonna just be safe here and put like 4 decimal places just to be extra good. So that's one answer. The other answer is if I subtracted, but I notice what happens when I subtract in the numerator. Then I'm going to taking a small whole number, not small, but it's a whole number, a positive number, and I'm subtracting a larger negative number. I'm going to get negative in the numerator and then divide by a positive and get a negative answer. So, and saying negative hours isn't going to make sense. So this is our only answer here. Do be careful because like when we're doing these type of word problems, we have to always kind of, especially with these problems where there's 2 different answers, a lot of times, one of those answers doesn't make sense. It doesn't make sense to say like, oh, I have negative 2 hours left in the day or something. So that answer would just automatically be kicked out. So this is our only answer. There we go. All right. I hope you find this valuable. I know these numbers are really big and are hard to deal with, but it might help using you can use the free online graphing calculator to kind of, if you're using like too basic of a calculator, it might not be able to find these large numbers for you. I just use my cell phone calculator and it seemed to work just fine though. You can use the class calc if you just Google classcalc.com or just class calc, just Google class calc. They have a graphing calculator that should make these calculations pretty easy. All right, have a great day. Bye.